Join me as I dive into the wild world of tachyons to see if they can really break the speed of light and even mess with time. So, what exactly are tachyons? In short, they're particles that are theorized to travel faster than the speed of light, which, as we all know, is a fundamental limit in physics. But what makes them so fascinating is their potential to challenge our understanding of space and time. From science fiction to serious scientific research, tachyons have captured the imagination of many, and for good reason. They could be the key to unlocking new possibilities in the universe, and that's what makes them so exciting. One of the biggest challenges with tachyons is that they seem to defy the laws of physics as we know them. According to Einstein's theory of relativity, nothing can travel faster than the speed of light. But if tachyons do exist, that would mean they're somehow able to bypass this fundamental limit. This raises all sorts of paradoxes and logical inconsistencies, particularly when it comes to causality. For example, if a tachyon was sent from point A to point B faster than the speed of light, what would happen if it was observed at point B before it was even sent from point A? It's mind-bending stuff like this that makes tachyons so difficult to wrap your head around. Another major issue with tachyons is that they would require a significant rethinking of our understanding of space and time. If particles can travel faster than light, that means our traditional notions of distance and time would need to be rewritten. It's a tall order, to say the least, and it's why many physicists are skeptical about the existence of tachyons. However, that doesn't mean they're not worth exploring. After all, some of the most groundbreaking discoveries in science have come from challenging established theories and pushing the boundaries of what we thought was possible. The implications of tachyons are so profound that they could potentially upset the entire apple cart of modern physics. And yet, despite the challenges and contradictions, there are some theoretical frameworks that suggest tachyons could be real. For example, certain solutions to Einstein's equations of general relativity do allow for the existence of faster-than-light particles. It's a tantalizing prospect, to say the least, and one that has driven physicists to continue exploring the possibility of tachyons. Theoretical work aside, there have been some experimental attempts to detect tachyons. While none of these efforts have been successful so far, they do demonstrate the ongoing interest in this area of research. For instance, the Large Electron Positron Collider at CERN was used to search for evidence of tachyons in the 1990s. More recently, researchers have proposed using high-energy particle colliders to detect signs of tachyonic particles. It's a long shot, perhaps, but the payoff could be enormous if tachyons are eventually discovered. One of the most intriguing aspects of tachyons is their potential to change our understanding of time and space. If particles can travel faster than light, that means they could potentially move through time as well. This raises all sorts of possibilities, from time travel to communication with parallel universes. It's the kind of stuff that's usually relegated to the realm of science fiction, but with tachyons, it's at least theoretically possible. Of course, the concept of time travel is a notoriously tricky one, and even if tachyons do exist, it's unlikely that we'd be able to harness their power for some kind of time-traveling machine. Still, the idea that we could potentially manipulate time and space in ways previously thought impossible is a tantalizing one. It's what drives physicists to continue exploring the mysteries of the universe, and it's what makes tachyons so fascinating. Tachyons are a mind-bending concept that challenges our understanding of the universe and pushes the boundaries of what we thought was possible. They may or may not exist, but the debate surrounding them is a crucial part of the scientific process. By exploring the theoretical implications of tachyons and pushing the limits of what we know, we may just stumble upon something entirely new and revolutionary. Thanks for watching, and don't forget to share your thoughts on tachyons in the comments below. If you liked this video, be sure to check out my other videos on related scientific topics.